needs computation and analysis. It has its general assumptions that we need to know before creating this table that will be discussed later on as I teach you the process. The process of informal trial and error technique. First, this is the worksheet or the table used in this technique. This table is the medium for this technique and in which where the aggregate planner computes and evaluates the information gathered like the forecasted demand, the capacity, unit cost, and other variables needed in order to meet the demand requirement. This table can be used in a computer through Microsoft Excel and other spreadsheet application. Its chief disadvantage of such technique is that they do not necessarily result in the optimal aggregate plan. The second process. In order to use this table, we must compute the following variables. First, number of workers in a period. Second, inventory at the end of a period. In such special case, if amount used to satisfy demand in the current period is higher than the total of inventory at the end of the previous period or the beginning inventory and the production in the current period, it will result to backlog. And inventory end is 0 and not a negative value. Third, the average inventory for a period. Fourth, cost for a period, which is the bottom line of the table or the worksheet. Formulas extracted from the latter formula are as follows: the output cost, the regular cost, the overtime cost, the subcontract cost, the hire or layoff cost, such as for the hire cost, layoff, inventory, back order. The third process. It is important for aggregate planners to know first the assumptions used in this technique before evaluating the aggregate plan, and so here are the following general assumptions used in this technique. First, the regular output capacity is the same in all periods. No allowance is made for holidays and different numbers of workdays in different months and so on. Second, cost such as back order, inventory, subcontracting, and etc. is a linear function composed of a unit cost and number of units. Third, plans are feasible, that is, sufficient inventory capacity exists to accommodate a plan. Subcontractors with appropriate quality and capacity are standing by, and changes in output can be made as needed. Fourth, all costs associated with a decision option can be represented by a lump sum or by unit costs that are independent of the quantity involved. Fifth, cost figures can be reasonably estimated and are constant for the planning horizon. Sixth, inventories are built up and drawn down at a uniform rate, and output occurs at a uniform rate throughout each period. However, backlogs are treated as if they exist for an entire period, even though in periods where they initially appear, they would tend to build up toward the end of the period. Note that some assumptions given are realistic and some are unrealistic for some periods or for some circumstance in a company. The reason for this is that the general purpose of this technique is to simplify the computation and to avoid sophisticated assumptions, informations, and computation that will make this table non-understandable. The second technique is the mathematical technique. The mathematical technique is much complicated than the trial and error. However, a lot of research had been done in this method, and it is used as a basis for comparing the effectiveness of alternative techniques for aggregate planning. Again, the mathematical technique is subdivided into two, such as linear programming and simulation model. The linear programming are methods for obtaining optimal solutions to problems involving allocation of scarce resources in terms of cost minimization added or profit maximization. Its difference to the previous technique is that it gives us the optimal and aggregate plan which the previous technique cannot be done. However, it is more complex than the informal trial and error technique, and sometimes such computation becomes too sophisticated and unrealistic. Its purpose is to minimize the sum of costs related to regular labor time, overtime, subcontracting, carrying inventory, and costs associated with changing the size of the workforce. Its goal is to obtain aggregate plans that would match capacities with demand requirement. However, its major constraints are the capacities of the workforce, the inventories, and the subcontracting. The process of linear programming. First, this is the table or model used in this technique. The second process. Here are the variables in the table. R means regular production cost per unit. T means overtime cost per unit. S means subcontracting cost per unit. H means holding cost per unit period. B means back order cost per unit per period. N means number of periods in planning horizon. The second category of mathematical technique is the simulation model. It is a computerized models that can be tested under different scenarios to identify acceptable solutions to problem. The book did not quite discuss this module because it is a computer program used by some businesses. The aggregate planning in services firms. The process of aggregate planning in service takes into account projected customer demands, equipment capacities, and labor capacities. Therefore, this is also the gathering of information process. Its end product or result is a time-phased projection of service staff requirement. Examples of service organization that uses aggregate planning are as follows. First, in a hospital. Hospitals use aggregate planning to allocate funds, staff, and supplies to meet the demands of patients for their medical services. Second, airlines. Airlines use aggregate planning in wide range of factors such as planes, flight personnel, ground personnel, and multiple routes and landing or departure site. Also, capacity decisions must take into account the percentage of seats to be allocated to various fare classes in order to maximize the profit or yield. Third, the restaurants. Restaurants use aggregate planning by smoothing the service rate, determining the size of the workforce, managing demand to match a fixed capacity. The general approach usually involves building the inventory during the slack periods and depleting it during peak periods. It is similar to manufacturing aggregate planning because of their perishable inventory. Fourth, the other services. Other services such as financial, hospitality, transportation, and recreation services provide a high volume intangible output. Aggregate planning for this involves managing demand and planning for human resource requirements. Their goal is to accommodate peak demand and effective labor use. Manufacturing aggregate planning versus aggregate planning in services. First, demand for service can be difficult to predict. The reason for this is that the demand for service is quite more variable than the demand for manufacturing. Second, capacity availability can be difficult to predict because the processing requirements for services can sometimes be quite variable. The types of variety of a service firm are more pervasive than in a manufacturing, so making it more difficult to measure the capacity. Third, labor flexibility can be an advantage in services because labor often comprises a significant portion of service compared to manufacturing. That, coupled with the fact that service providers are often able to handle a fairly wide variety of service requirements, means that to some extent planning is easier than it is in manufacturing. Fourth, services occur when they are rendered. This means that most services cannot be inventoried, unlike to manufacturing, because services can be known once they are rendered. The demand requirement makes the difference more separate to each other because being variable of the demand, the service rendered results also to being variable. This concludes that because service capacity is perishable, aggregate planners need to take into account when deciding how to match supply and demand. The yield management is an approach that seeks to maximize revenue by using a strategy of variable pricing. Prices are set relative to capacity availability. The application of pricing strategies to allocate capacity among various categories of demand. After the aggregate planning technique, the second step for aggregate planning process is the disaggregating the aggregate plan. This process is the breaking down the aggregate plan into specific product requirements in order to determine labor requirements,